at that time that land will be withstand that missions capacity. Okay, that's why you can see the steam power station should be located at a place where land is cheap and further extension if necessary. So so you have to see that land. If suppose first you have to construct a thermal power station. So if in future generation there will be, you have to produce the large amount of high amount of electricity. At that time you have to, if suppose extend that thermal power station, at that time you can see there is a possibility or not there. Okay, so that is one thing. Moreover, the bearing capacity of the ground should be adequate so that heavy equipment could be installed. So already I will say that bearing capacity of the ground, that means land will be adequate so that a heavy equipment could be installed. That means we have to install the heavy equipment. So at that time that land will be withstand that high missions. Okay, so that is one thing. So next one is nearness to load centers. Okay, so after you have to generating the electricity, you have to must and should that the electrical energy will be transferred to the load centers. That means transmission. So see, in order to reduce the transmission cost, the plant should be located near the center of load. See, whenever you have to generate the electrical energy, next you have to supply to one grid. Okay, grid is nothing but one load. So either grid you have to connect the all near substations. Okay, that means is nothing but the load. Okay, so located near the center of the load. Why? Because so you have to so whenever you have to construct the thermal power station near to the center of the load. So whenever you have connect the center or near to center of the load, at that time transmission. So okay, the wire, so you have to transmit by using the wires. At that time the wire cost will be reduced. That means the transmission cost will be reduced. Okay. It is because, why? Because AC power can be transmitted at a high voltage with a consequent reduced transmission cost. Okay, so so AC power ni you have to transmit with high voltages. Okay, high voltages means at that time you have to use the high cost wires. So at that time, whenever you have reduced the distance, at that time the transmission cost will be also reduced. Therefore, it is possible to install the plant away from the load provided other conditions are fair. If suppose there is not possible to install, so therefore it is possible to install plant away from the load centers. So if suppose you have to, there will be no land near to the load center. So at that time you have to far away from the load centers. You have to install thermal power station. At that time you have to see other conditions are favorable or not. Okay. Next one is distance from populated areas. So why? Because so here you have to construct the thermal power stations away from the populated areas. Why? Because as huge amount of coal is burnt in a steam power station. So here in the thermal power station you have to burn the lot amount of coal. So at that time smoke, okay, fumes are polluting the surrounding areas. Okay, so this is necessity that the plant should be located at a considerable distance from the populated areas. That because of these regions, okay, the thermal power station will be constructed distance from the populated areas. Why? Because so whenever smoke, okay, fumes will be releases, so at the time there will be a populating area will be there. So at that time the human being will causes the breathing problems like this. Okay, that's why the thermal power station should be located, okay, distance from the populated areas. Okay, so these are the choice of site for the thermal power station. Okay, so whenever you have to choose one site or one place for the thermal power station, at that time you have must and should see supply of fuel, availability of water, transportation facilities, okay, as well as cost and type of land, okay, as well as nearness to load centers, okay, as well as distance from populated areas. Okay, these all parameters should be must and should consider to select a side to the thermal power station. Okay, next one, you can see efficiency of the thermal power station or steam power station. Okay, from the thermal power station you can get how much efficiency. See, the overall efficiency of a steam power station is quite low. Okay, so overall efficiency of the steam power station is about low. So So the efficiency will be, the thermal power station efficiency, overall efficiency will be 29%. Okay, due to mainly two reasons. So what are that reasons? Means firstly, a huge amount of heat is lost in the condenser. So whenever you have to rotate the turbine blades, so at that time that so you have to see in the operation of the layout of a thermal power station. So below the turbine you have to place a condenser. So whenever the turbine blades will be rotated, at that time the steam will be exhaust from the turbine blades. Okay, so at that time, and the steam will be condensed in the condenser. That's in that process a huge amount of heat will be lost in the condenser. Secondly, the heat losses occurs at various stages of the plants. So remaining stages also there will be heat loss will be occurs. Okay, so next one is what? Thermal efficiency. So thermal efficiency, so it is the ratio of heat equivalent of mechanical energy transmitted to the turbine shaft to the heat of combustion of coal is known as thermal energy. Okay, so the thermal efficiency is defined as the efficiency is nothing but output by input. Okay, so here thermal efficiency says that the ratio of heat equivalent of mechanical energy transmitted to the turbine. So whenever you have to given the mechanical energy to the turbine, okay, heat equivalent of mechanical energy, that ratio to the heat of combustion of coal. So in the boiler the heat will be combusted. Okay, that heat ratio will be called as the thermal efficiency. See, thermal efficiency, eta. So efficiency is always denoted with eta. Eta here thermal efficiency means you can indicate thermal. Eta thermal equal to heat equivalent of mechanical energy by heat of coal combustion into 100. So at that time you can get the thermal efficiency. So the thermal efficiency of a modern power steam power station is about 30%. Okay, the thermal efficiency of the modern steam power station is about 30%. So next you can see the overall efficiency. See, the ratio of heat equivalent of electrical output to the heat combustion of coal is known as overall efficiency of steam power station. That means the ratio of heat equivalent of electrical output. Finally, how much amount of electrical output you can get, that ratio to the, here also same, how much amount of heat of coal will be combusted in the boiler is known as the overall efficiency of the thermal power station. See here, the overall efficiency, eta overall is equal to heat equivalent of electrical output by heat of coal combustion into 100. Okay, this is the thermal efficiency and overall efficiency of the thermal power station. In some cases there will be a small problems, 2 marks problems will be maybe asked by the formulas of thermal efficiency and overall efficiency. Next, so in previous you can see the choice, that means selection of site for the thermal power station. Similarly, here you have to see the selection of site for nuclear power station. Okay, so here also for to select the to choose the site or place for the nuclear power station, these are the following factors. So first one, here also you can see must and should availability of water. Okay, see, as sufficient water is required for cooling purposes, therefore the plant site should be located where the ample quantity of water is available. Example, across a river or by seaside. So here also in a nuclear power station also you have to use the coolant. Okay, coolant, the coolant used is you have used. So already I have to discuss the nuclear power station layout. Okay, and what are the nuclear, yeah, so what is the main component used in the nuclear power station? The main component used in the nuclear power station is nuclear reactor. So okay, so in nuclear reactor you have to use the coolant to cool the heat. Okay, so after process will be completed. Okay, that means at that time also the nuclear power station will require the huge amount of water. That's why this nuclear power station is also constructed near a river or by seaside. Otherwise near seas you can construct the nuclear power station. Next one is what? Disposable of waste. See, the waste produced by the fission in the nuclear power station is generally radioactive, which must be disposed of properly to avoid health hazards. Therefore, the site selected for such a plant should be adequate arrangements for the disposable of radioactive waste. See, Here in nuclear power station, you have to use the nuclear elements. Nuclear elements are more radiation hazards. Okay, so more radiations will be released from the nuclear elements. So that's why the waste which is coming from the nuclear power station is properly disposed. Otherwise, it causes so many health hazards for the workers who are working in the nuclear power station, or so the population near to the nuclear power station. Okay, so that is also must and should factor to consider while choose a site for the nuclear power station. Okay, so next one is distance from populated areas. Here also, so already I am says that. So here you have to use the nuclear element materials. So whenever you have used the nuclear elements, at that time it releases a radioactive materials. So that's why the whenever you have to construct a nuclear power station, so at that time you have to choose the land or site away from the populated areas. So as there is a danger of presence of radioactivity in the atmosphere near the plant. So whenever you have to whenever you have to construct the nuclear power stations, so at that time from the nuclear power stations the radioactive elements will be releases. So releases in the atmosphere. So whenever the atmosphere surrounding the nuclear power plants will be polluted, at that time it pollutes the population near the nuclear power station. So at that time you have to construct the nuclear power station distance away from the populated areas. So next you have to see the transportation facilities. Okay, same here also previous one like this, the site selected for a nuclear power station should have adequate facilities, okay, in order to transport the heavy equipment during the erection and to facilitate the movement of the workers employees in the plant. Okay, here also to transport the equipment, okay, to the power station and for the movement of workers employees. So so you have to choose the transport a proper transport adequate facilities of transportation. Okay, so these are the factors must and should to select a site for the nuclear power station. What are those? Availability of water, disposable of waste, okay, distance from populated areas, transportation facilities. Next you can see the choice of site for hydroelectric power station. So here also the followings are taken into account while selecting site for a hydroelectric power station. Okay, so to choose a site for a hydroelectrical power station, here also hydro, the name itself indicates, so it having a huge amount, lot of water to generate the electricity. Here the electricity is generated by using the water only. Okay, that's why the primary requirement of a hydroelectric power station is the availability of huge quantity of water. Okay, so that means here you require the huge quantity of water. Such plants should be built to place a example river or canal where adequate water is available to good head. Okay, so that means the power station, the hydroelectrical power station are classified depending upon the head. Head means the height of the water level is nothing but the head. Okay, so that means wherever you have the good head, that means good water level. So at that place you have to construct the hydroelectric power station. That is mainly the hydroelectric power station is constructed near the river or canal. Next one here also transportation facilities. Okay, the site selected for a hydroelectric plant should be accessible by rail and road so that necessary equipment and machinery could be easily transported. Okay, so here also, okay, whenever you have to construct the nuclear power station, okay, here also transportation, sorry, hydroelectric power plant, so there will be accessible by rail and road so that necessary equipment and machinery could be easily transported. To transport the missions and equipment to the hydroelectric power station, there will be adequate transportation facilities. Okay, so those are the so next one is storage of water. Okay, so see, so to generate the electricity by using the water, so I will say that you have to in previous class, so I will say that you have to must and should store the water. Okay, that's why it is necessary to store water by constructing the dam. okay, by constructing the dam, and they have to store a water in order to ensure the generation of power throughout the year. Okay, so water is available mostly, huge amount of water will be available in the rainy seasons. If the suppose there is no storage, so at that time the water will be flowing. So at that time there is scarcity of water will be occurs in the summer seasons. Okay, that's why you have to must and should it is necessary to store water by constructing a dam in order to ensure the generation of power throughout the year. Okay, the storage helps in equalizing the flow of water so that any excess quantity of water at a certain period of the year, okay, can be made available during the times of very low flow in the river. So if suppose you have to store excess quantity of water, so if suppose in summer seasons at the times there will be a low level of water in the river, at that time you have to supply the water from the dam. Okay, so that's why must and should you have to storage of the water. Next one, cost and type of land. Okay, so the land for the construction of the plant should be available at a reasonable price. Here also hydroelectrical power plant means it is also constructed in a 100 acres of land. So at that time the cost will be, so to choose the cost where the so where the cost will is where the land cost available in a reasonable price. Further, the bearing capacity of the ground should be adequate to withstand the weight of the heavy equipment to be installed. Okay, here also same. So the land bearing capacity also should adequate. So why? Because here also you have to install the heavy equipment. Okay, so transportation facilities. Okay, these are the factors to choose the combustion should consider to choose the land for the hydroelectric power station. So next one, see, you have to see the hydroelectrical power plants are you have to see classified depending upon the head, that is low head, medium head, high head. Already I will say that. So here also, so these plants, another type classification is there. These are classified depending upon the base load and peak load. Okay, now we have to see what is the base load and what is the peak load. See, base load is also called continuous load. It is relatively stable and refers to the minimum amount of electrical demand over a 24-hour period. Okay, so constant, if suppose if a day you have 24 hours, okay, the load which is supplied continuous constant, okay, constant continuous load minimum amount, that means constant minimum load will be supplied over a 24-hour, that load is called base load. Effectively the constant power required by the home or business over 24 hours is called a base load. So constant load means constant load you have to use in a homes or in a business. Okay, so that load is called a base load. This includes appliances that require a constant source of power such as IT systems, alarm systems, machinery, security lights which are not turned on and off. Okay, so that means which are not on and off, IT systems, missions, security lights, these are all using the base load. Base load power plant, a power plant that is responsible for base load power needs it to be run continuously and consistently without being shut down is called base load power plant. Okay, a power plant is responsible for base load power needs. Okay, base, so what are the necessity power needs without being shut down? Okay, without shut off, the load will be act, that is called base load power plant. Examples of base load power plants are coal fired thermal power plant, hydroelectric power plant. Okay, coal thermal, that means thermal power plant and hydroelectrical power plants are the examples for the base load power plant. Runoff river without foundation, geothermal power plant, tidal power plant, nuclear power plant. Okay, geothermal and tidal power plant are you have to later discuss in the second unit. These are also examples of the base load power plant. Okay, peak load. Peak load is nothing but peak load is typically a short period of time with high demand. See, if suppose you have to consider a 24 hours, so in 24 hours at a short period of time, either in a 1 hour or 2 hours, you have to at a time use a high demand, okay, high energy. Okay, it is far less predictable than the base load. Okay, as it is spiked when, for example, heating or air conditions are turned on. So that means whenever you have to use the heaters, air conditioners, whenever you have to use the air conditioners means, so mostly you have to use in the air conditions night time. So whenever all of the people use the air conditions in the night time, at that time the load used in the houses will be goes to high demand. Okay, that is nothing but the peak load. Okay, due to high demand, peak electricity is more expensive. Whenever you have to use the peak load, at that time our electricity also consumed is more, our electricity is also more expensive. Okay, so peak load power plant, a power plant, okay, that is responsible for peak demand needs is called peak load power plant. Okay, so whenever you have to require the power plant for the peak demands, okay, that is called peak load power plant. They are started up whenever there is a spike in the demand and stopped when the demand restraint. Okay, so whenever you have to you have to demand the high power, so at that time you have to use the high peak load power plant. So examples of gas load power plant are gas plant, hydroelectric power station, runoff. So hydroelectric power stations also there are. So here see in base load, in base load you have to use the runoff river without poundage. So here you have to, in a peak load you have to use the runoff river with poundage. Solar power plants, wind turbines, diesel generators. These all are the examples of the peak load power plants. The base load and peak load are shown in the figure. See here, this is a constant. So here I have to see the graphical representation. Okay, here you have to take the hours time period and you have to use the load. How much load will be used? This is a constant. Base load is nothing but constant. Okay, up to here you have to constant load. This one is constant load. Here this is a peak load. You have to use the highest demand. Okay, these two are the peak loads. Okay. Load curve. So load curve is nothing but load curve or chronological curve is the graphical representation of load in kilowatts or megawatts in proper time sequence and the time hours as shown in figure. Okay, this is also called as a load curve. Okay, load curve is nothing but the representation of the load. How much load will be used is represented with the time. That is nothing but, that is a graphical representation. That is nothing but the load curve. The load curve of the power system is not same all the day. It differs from the day to day and season to season. So the load curve is nothing but how much amount of electrical energy is used. That means how much of the load is used will be shown with the time period. Okay, it is not same all the day. Why? Because in daytime you are not use the lights. But in night time you have to use the lights, fans, etc. all. So that time, at that time the energy required is changes. So at that time the load curve is also changes. It differs from day to day. So you suppose in this day you have to use for suppose a high amount of electricity. In other day you have to use the low amount of energy. So that means here, here the load curve is also differs from day to day and season to season. So in rainy seasons, that means in winter season you have to no use of air conditions. But in summer seasons we have to use the air conditions, refrigerators, etc. So at that time the energy utilization will be increases. So at that time the load curve will be differs from day to day and season to season. See, this is the load curve, time, load. Okay. So this is the graphical representation. Sometimes you have to use the low amount of energy. So, and this will be increases and will be decreases like this. Okay. Okay. Load duration curve. So you have to see the load curve is nothing but, so the load curve is nothing but you have to represent the load with respect to the time period. So load duration curve is defined as the curve between the load and time. So that means in which the ordinates representing the load decreasing the magnitude. That means here you have to draw the curve by decreasing the magnitude. That means first, so you suppose in which you have to per day you have, for suppose you have to, so here you have to load duration curves also different types. Daily load curve or daily load duration curve, monthly load curve or yearly load curve. That means daily load curve represents the daily in 24 hours you have to draw the curve how much amount of load will be utilized and you have to represent the time in 24 hours. In load monthly load curve you have to represent the months. That means days. Okay, 30 days and you have to use and you have to represent the load. Okay, how much amount of load will be. In yearly load curve you have to represent the months. Okay, months and you have to represent the load. So that means if suppose if you have to take for example in daily load curve, so in 24 hours you have to not use the same amount of load. So in daytime you have to In one time period, you have to use the one amount of load. In other time period, you have to use the another amount of load, like this. So here load duration curve means which ordinates representing the load in the decreasing the magnitude. That means in a load duration curve, you have to represent the first high amount of load, okay, in which you use in which time period. So next decreasing order. See, you have to see the diagram, you have to understand. See, this is the time in hours, 24 hours. Okay, so in 24 hours, first 0 to 4 hours, you have to represent the, so 30 megawatts. That means in a day, in total 24 hours, for 4 hours, you have to use the highest demand, 30 megawatts. So next, 4 to 9 means in between, in 24 hours, in 5 hours, you have to use 20 megawatts. That means you have to first increase highest magnitude, next decreasing order. So this is nothing but the load duration curve. Okay, so expression for hydropower. Okay, so that means to represent the power, okay, power developed in the hydroelectrical power plant. That means electrical energy. Okay, electrical energy you have to represent in the power. Mechanical power can be expressed as P equal to Q rho GHN, where P means mechanical power in kilowatts, Q means flow of rate pipe, rate in pipe or discharge in meter. So here you have to use the through a pipe, so you have to supply the water to the turbines. Okay, the flow of water rate will be represented in Q. Rho means density of the water in kg per meter cube. G means acceleration of gravity in meter per second square. Eta, eta is nothing but global efficient ratio of between the 0.1 to this one. Okay, so this is the expression for the hydropower. Okay, so in this class we are discussing about the selection of site for the thermal power station, nuclear power station, as well as the hydro power station, and efficiency of thermal power station, and what is the base load, okay, and what is the peak load, and what is the load curve, okay, and what is the load duration curve. Okay, so up to now here you have to complete the first unit. Okay, in next class I will start the second unit.